Hello again, this is Tim Baldridge. I want to talk a little more today about Odin, and I want to talk a little bit about LCons and sequences of variables and logic variables. So I ran into something recently while I was prototyping some code, um, and that's something like this. Let's say we have for query here, and then we want to unify. And I'm in the actual unification namespace now. So I want to unify 1, 2, and 3 with something like this, x, y, and z. And then in my result, I want to do something like pull out y, right? And if we wrap this in vec to see what our output is, let's see here. Persistent vector cannot be cast. Oh, this needs to be equals because we're in this namespace here. There we go. So that's what we want to do, right? We want to pull out this second value, kind of this pattern matching thing. But what this requires is the unification of two sequences. So we have a sequence A and sequence B, 1, 2, and 3 unifying to X, Y, and Z. You know, one of the things of Odin is supposedly it's good at unification, and we can extend the unification. So I thought, hey, we'll go in and we'll unify. We'll add a new overload to our unification engine to allow different unification based on sequential. So what I originally did was I had in here first and Clojure, core first and next, right? So if we have two sequential items that we're unifying together, then we're going to unify the first thing with the first thing, and the second thing with or unify the first thing of both sequences, A and B, right? And then we're going to continue unifying the next thing down, right? So this is we're gonna unify the tail of each sequence and kind of recursively go through this. So this is a recursive algorithm here, and in fact it does consume stack space because we're using multi-methods. We don't really have the ability to do a proper recur, so you know we will run out of stack space if the sequences are very long, but most of the time I don't think we're going to run into that in normal uses. So that works. And so if we go back here, we see that you know we get what we expect, right? And we can say, okay, so if the first item is 1 and the second item is 3, this still works properly. And if we say 4, this does not unify, right? So it's a positional type thing. And what we're doing is when we unify the first two items and the second two. So 2 is to y and 3 doesn't unify to 4, so the whole thing fails. Now, what's interesting about this though too is because it is recursive, we should be able to do something like this. Well, if we turn this back to 3, right? And that in fact works. In fact, if we put x here and 2 here and change this to x and we run this, we can see that we can actually dig down fairly deep. In fact, if we just go to x like this, we get to the vector itself. So this is really kind of cool. We're allowed to just replace parts of this data structure with part of the sequence data structure with logic variables. So now that works all well and good, but we have another problem. That problem is that what we want to say sometimes is if something starts. So if we want to get the first item, right, we just want x. This doesn't work. Actually, it doesn't work because I don't have an overload for this either, which is a bug case we should fix. We get this error because nil is not a type, so this is not properly going to object. It should be going to object in the sense of like we should be unifying sequential with object, which would pass, or object and object. But nil here is not an object. So I just need to fix that up in the code. But the problem still stands that even if we did fix that, it still wouldn't work because this x here, this vector only has one item, right? And so we need a way to say that we don't care about the rest. So in order to do that, we need something that's known as a logic cons. We're basically, or an LCons is what we're going to call it. We're basically, what we want is a pair. But what we want is, so if we can think of a pair in Clojure, right, we have head and tail, and this is different in Clojure than it is in other languages, right? So what we really want is a Here we go. We want cons of head and tail. Now here's the problem, right? We want to be able to say cons 1 onto tail, where tail is a logic variable. But if we do this, we get this error. Don't know how to create iSeek from keyword. This is because in Clojure's iSeek protocol, where the cons and everything is built off of, it's typed. It's actually typed, which means that the tail of a sequence can't just be an object. It has to be an iSeek, something that implements iSeek. Well, and we don't. Our logic variables and keyword in this case do not implement iSeek, so we have to find a different way of doing that. So with this unification engine, it got a little bit complicated. So I went and created a protocol called LCons, and this defines L first and L next. Looks just like Seek, but it's a protocol. And then we have LCons that doesn't have this restriction. They can just be any object, this and head and tail. Now the problem is that this LCons is not sequential. Now we could do that. We could say here where both of them are sequential, right? But the problem is that this thing here, what we really want to say is ILCons, right? Or the ILCons and ILCons. But this def method overload doesn't work on that sort of basis. You can't put a protocol in there. It has to be an interface. So I kind of hacked this in differently. And there might actually be a way to improve this by having this also implement sequential, because sequential is just a marker that says you can call seek on a thing. So we would have to break that contract or implement seek, which we can't do. There's just it's ugly. So what I ended up doing here is redoing our dispatch method and our multi method, so that we create our types based on type 4 and not just type. And type 4 is defined by, if it satisfies ILCons, we return sequential. Otherwise, we return the type of the thing. So this is kind of a hacky way, I guess, of getting a protocol into this def method dispatch chain. And there might be a way to write our own version of def method that does support protocols. I haven't spent a whole lot of time thinking or working on that, but that might be a possibility as well. So all that to say, that gives us the ability to unify with LCons. Now, I also did fix up in the main namespace here. We have LCons as a what do you call it? A primitive. So what we can actually do now is say something like this, and we can say our initially we are going to have v unify to 1, 2, and 3, and then what we're going to do is we are going to say LCons x tail is nothing and the full thing is v. So what this is basically, we could make versions of this, right? We could say first head cons, right? And we could have this as a rule. Def rule head and cons. And what we could say here is that we want this to unify in such a way that we have head and we don't care what the tail is, and cons, right? And that's going to complain because first already exists in this namespace because it got pulled in, but we can fix that up in a little bit. So I mean, if we run this code here, we get what we expect. That's pulling out 1, and whatever the rest of it is just being thrown away. And we should be able to replace this with first and do this. We did this wrong. This should be LCons. There we go. There we go. So there we have first, and we could do the same with next, right? And next is the same thing, but we don't care what the first is in the case of next. And we can just call that tail. We have another rule. And the tail of v is 2, 3, right? So we have this way of working with sequences now. And what this actually is really helpful for is one of the situations I ran into is where I had a rule like this that took multiple logic variables, bind, range like this. So max, range. We can try this. See if this works. Project, range, max to range. So this is kind of a, I guess it's a pivot, and that what we're doing is we are binding variables to bind range. So we'll see how it works here too, x and y. And if we output x and y, y here, there we go. We get 0 and 1. So this is what I was trying to do that led me to implement this in the engine, is that I had a bunch of variables I wanted to bind individually to the things in a sequence, right? So if we could set this to 3, and now we got these things bound, 1, 0, 1, 2, and we could just, z like this. So that's helpful if you kind of are working with a data set that's been pivoted, and that is to say that you have something that's in a bunch of columns, like 1, 2, and 3, and you want to bind that into x, y, and z. With project, we could have also done this, which would have resulted in a disjunction. So if you see here, we have one result with 0, 1, and 2. If we replace this with a binding form like this, then what we get is 3 results, 0, 1, and 2, right? So it's just a different way of looking at the data. But the sort of dealing with lists and logic variables in this way, and these logic lists, is very helpful. It's helpful too for when you build up sub-results and that sort of thing. So you can have a recursive query and you can build up the path using these logic cons. So that's the tutorial for today. I think there's a way we could extend this. So if you think about it, vectors of this nature or sequences of this nature are kind of key value pairs where the key is the index and the value is the value at that index. And I think we could extend this to work with maps. And I haven't tried this yet, but it should be possible, so that we could pull out parts of hash maps and that sort of thing. I'll have to think a little bit about what that looks like and how that works and play around with it a bit, but I think we should be able to do that. So anyway, that is the tutorial for today. Hopefully that was useful for you. I did release a version of Odin recently. It doesn't have this code in it, but it has all the code up to this. And hopefully you'll find that useful. And then in the next tutorial, I want to actually go over higher order. You can see here I have this thing called invoke. It's another thing I worked on recently, which is the ability to have a rule be in a logic var. So you can pass a rule into a rule, kind of higher order rules, and have those be run in certain situations. So it's kind of like higher order functions where you pass functions into functions. And we can start to do some stuff like that in this engine as well, which gets to be kind of cool. Once again, that's all I have for today. Thank you so much for watching.